Hi, it's Pavel with another C# homework, chapter 5, homework 38 from C# 2012, How to Program. And today we're going to do a little math going from so-called infinite series. We are going to calculate the mathematical constant E, which is Euler's or Euler's number, not sure how to pronounce it. So let's see first what that number actually is. So it's a constant, so it's a kind of like pi. It's a given number, and this is the number. Now C# provides a function, or a method to calculate the number, which is simply math dot capital E, and it will give you the constant, just like you have math dot pi. But you can also calculate the number programmatically, or using a math, simply calculations, and this is the formula: 1 plus factorials of 1 divided by 1, so that's 1, then factorial of half, a third, factorial of fourth, and so forth. And the idea is that the higher the number, the closer you'll get to this actual constant. In other words, if your number starts only with 1, the result is only 2.0 instead of 2.71692 and so forth. So normally you would just use the C# method, but in this exercise we're going to do both. We're going to calculate our constant in a formula as well, and then compare it to the actual constant that the C# provides. So let's have a look again. This is the formula that we're going to use, and this is the class math.E that we will compare our results to, and they should be close enough. And again, the higher our number is going to be, the closer they will match. Now, so we are going to use or have to calculate some factorials. So we'll need to do some looping, obviously, for that, and we will need to get some variables in place. Now I'm going to do a constant integer original value. This is the value that the user would enter. I'm not going to ask user for the input. I will simply plug it in directly into the formula. Let's start with 1, for example. And this is the number that we will keep changing and see the results. Now, so this is a constant, but we need to assign that. I'm going to use a constant just so I can change the value in one place, and it will, propagate throughout the whole program instead of using some actual numbers throughout the program. I'll use the variables. So another one, I will declare value. I will initialize it to 0, and you'll see all these variables what they're used for when I go to the looping and calculate the factorial. And int factorial equals 0. Now I will assign the value will equal the original value, and this is the value that will be that I will be using throughout the calculation. So let's do our loop. While our value is greater than 0, we will calculate some factorials. Now I need to account for a value of 1. Because if you look at the formula, that's this. This is added to all the calculations of the factorials. So if value equals to 1, and In other words, if this is actually the last loop, the last iteration of the loop, then my factorial will equals to 1 as well. In other words, I won't be adding anything or calculating factorial. Factorial of 1 is 1 anyway. So else, in other words, for everything else, if it's not 1, I will have to loop, perform some loop to calculate the factorial. Remember, factorial is, let's say a factorial number of 5 is 5 times 4 times 3 times 2 times 1. So I have to loop through that. So let's do the index equals, let's find out how many times we'll have to loop, which is the number itself, value. Let's say it's 5. So we will do 5 iterations of the loop, but it's starting from 0. That's why there's -1. So because it will be 0, 1, 2, 3, and 4. And our factorial will equal to the value. Again, if the value is 2, this is skipped and it goes to this portion of the code. And now we're gonna loop through it. So while our index is greater than 0, again, we're calculating the index now, not the value. Then factorial equals times equals index. In other words, we will multiply the index to the factorial with each iteration, and we have to, of course, adjust our index or decrease it. So in other words, again, let's assume the value is 5. Let's do this. 5. So our value equals 5 now. So we will loop until value equals is greater than 0. So we'll actually, I have to over here. Let me see. I have to do the value minus because otherwise it would always equal 5. It would always be greater than 0. All right. So let's assume the value is 5. We loop in the first time, which is 5. Is value if value equals 1? No. So we go over here. So index will equal 4, and factorial will equal 5. Then we go to our loop. We'll calculate 5 times 4. Then we calculate 20 because 5 times 4 is 20. So 20 times 3, that's 60. Then we calculate 60 times 2, and then 120 because 60 times 2 is 120. Then 120 times 1, and it's calculated. So that's how it works. Now, the formula, of course, is not just factorial. We need to add 1 to it as well. So, we will kind of plug the factorial into the rest of the formula, which will be basically e. Oops. I need the. Of course, I need the e. I forgot the main variable, which is gonna be the double e equals 1. That's what we are going to calculate. That's this. E equals all that. So our e plus equals, we will have to convert to double to double and 1. And divided by factorial. Now remember, e already has the value of 1, like I said, and the rest of it, the convert to double 1, that's this, because every part of that factorial is 1 divided by factorial of 1, and then 1 divided by factorial of 2. So that's this one equals 1. I'm sorry, it's this one, and then this one in the other loop, the other iteration, and another iteration divided by the factorial. And we'll add each of them to our variable e, and after the loop, this loop completes, e will hold the result. All right, so and we currently need to double because we need we need a result in double. Otherwise, we would just get a 0 because the number would be so low. And if it was an integer, 1 divided by like 0 point something, I mean 1 is divided by like 5 or something like that. It's 0 point, and if it was an integer, it would be just a 0. So that's why we are converting this 1 to double to get the result as a double and store it in our variable e, which is a double. All right, so let's display the results. So console.WriteLine result of our formula is, and let's hold it in our placeholder, and let's use a number with 4 decimal places, and it equals e. And on the other line, we will simply display the result of the math class. So result of Math.E is, and again we'll do the 4 points, 4 decimals number, and it will be simply Math.E. See, this is the actual class and the actual method that will give us what we are we are trying to calculate manually. And in a perfect world they would match, but as you will soon see, they will not match exactly. Read line so we can read the output. All right, so let's see what this is going to give us. All right, so if our value equals 3, the result of our formula is 2.667, and what we are trying to get is 2.7183, which is the actual constant. Right, so let's if the number is only, oops, I have to close it first. So if our number is only 1, our formula should give us a result of 2. Yeah, so the lower the number, the further from the actual constant we get. Now if we get a, let's say, value of 10, then we should get very close to the actual, or we should actually already match. In other words, the higher the number, the better results our formula will, or the closer to the actual constant our formula will get. So there you have it. This is the how to calculate it. Again, we will go and calculate the factorial of each number. Remember the formula. So we will calculate factorial of 1, factorial of 2, factorial of 3. Then we will use it in our actual formula, which is the 1 divided by the factorial, and add it to our variable e, which at the beginning already equals 1, which is this. Otherwise, at the end, if it didn't equal 1, it will say it equals 0. Over here, I would have to simply add e plus equals 1. But this way, since it's already initiated to 1, I don't have to do that. And then we will output the result and compare it to the Math.E. And that's all there is to it. Hope it helped you, and I'll see you next time. Take care.